Oh, there it is. So in lab, this is a makeup lab for one individual, but we roll a ball down an incline, and you can focus on the red spot, which you might be able to see going around. If you do stop motion, you can. Okay? Now my question is, we did the experiment earlier where we collided a ball with another one and then observed how far each ball travels as it falls to the floor, how far it travels in the horizontal direction, which gave us the velocity of each ball after the collision. Now the problem with that is we found that there was more momentum after collision than there was before, immediately after collision there was before. And that is because, I believe, this ball is obviously rotating, so there's rotational kinetic energy, right? And of course we're looking at momentum, but still there's a rotational kinetic energy. And when it hits this ball, it doesn't lose all of its rotational energy. So if it's still spinning after the collision, then it grabs this surface and speeds up in a way that it wouldn't if it was an isolated collision. An isolated collision of the two balls. Two balls are not an isolated system in this sense. Okay? That make sense? So we've got some videos that attempt to get a handle on this. And I've asked that you take a certain amount of data on these, which can be done relatively quickly. The videos include a swinging pendulum, I think of length 26.5 centimeters, but you can time the thing. You know, you have a video, there are a lot of cycles. You can figure out what the period of motion of the pendulum is. You can see what the changing amplitude is, and you can estimate where the pendulum is, which means you can estimate where it is in its, where the reference point would be on the unit circle. And if you know reference point, reference point, reference point, reference point, you can calculate the time intervals very easily. And we can then determine a lot about how long it takes, you know, doing a little stop action, okay? Stopping the thing very quickly, several repetitions. You pick up different frames in your repetitions and get a very good picture of the angular motion of the ball before and after collision. And plus, you know, lots of information about the acceleration of the ball on the incline, all kinds of things we can find. One problem with that data is that the red ball gets, the red dot on the ball gets a little blurry, okay? If the ball's spinning fast, the red dot is a little bit hard to see. So it becomes a red blur, but you can tell which side of the ball it's on. Okay, and sometimes you get a frame that catches it real well. Sometimes it blurs. With repeated observations, you can sort through that sort of data and come up again with, I think, a very good analysis of both the translational and rotational motion of both balls. Okay? And then we learn something and see if we can explain the anomaly that we got when we did the experiment. Okay?